Hello everybody. In this lecture we want to talk about the optimization applications. So there are many applications that we need optimization techniques to find out what is the optimal decision for doing that. Let me give you a very simple example. Suppose you want to construct a bridge and you want to find out how you should do it. Definitely you want to do it in an optimal way. So the decision variables are some let me name some of these decision variables. So, for example, you want to know if you want to create a bridge between 2 points, how many piles are needed? What is the optimal distance between these 2 piles? And also how much cost is needed for doing that construction? How many workers do you need for doing that in a minimum time? And which materials you have to use in order to minimize the environmental undesired impacts, and so on and so on. Okay, so you can see here that there are several issues associated with each optimization problem. So those objective functions and decision variables are dependent on the application. So let me give you another example. Suppose you want to build an aircraft, okay, and also you want to know, for example, how much fuel does it need, what is the aerodynamic constraints that should be satisfied, how much material do you need, what is the cost of building such a huge object, okay, and what are the safety issues. So you want to decide in an optimal way to better use your resources, okay. So for this purpose, you need to know how to deal with different kind of constraint creation and how to find out what is the optimal decisions in this regard. Okay. So different optimization problems can be categorized into some categories. For example, single objective optimization. So in this type of optimization, you only have one objective function, and also you have a multiple number of constraints, okay? So this is one way of dealing with the optimization. The other way is, for example, you have multiple objective functions and you want to find out what is the optimal decision variables in order to not only satisfy the decision constraints, but also the objective functions are both optimized. They can be minimized or they can be maximized, okay? And sometimes the objective function is inside the constraint. So you can see here the objective function 2 is inside the constraint. For example, let's say we want to maximize OF1 and we have an additional constraint saying that OF2 should be, for example, less than something or bigger than something, okay? So this is called multi-level optimization. So at the upper level we have some objectives, and at the lower level we have other objectives. And for each type of optimizations, we need to know how to deal with them. Okay, that's it very much. Python installation. This is the beginning of using this course. So first of all, you have to turn on your PC or laptop, and then go and Google the Anaconda, and then go to the part that has the installation files. So in the Windows it has 2 versions, 64-bit and 32-bit, and also in the Mac operation system and the Linux as well. So choose the right platform and download the appropriate version and install it on your machine. Okay, once the Anaconda is installed, then you can easily use the Python editor and also the Pyomo package and so on and so on. So this is the way I recommend start this course, because it's much easier and it will result in a less hassle kind of programming at the beginning. So but I should say that if you want to use any other platform like PyCharm or any other platform for doing editing your Python codes, feel free to do that. Okay, so once you finish installation of Anaconda, you have to go to the Home tab, and then launch the notebook, a Jupyter notebook, and it will start like this. You can go to the file, new notebook, Python 3, and then a new page will open, and you can start your coding. Okay, so and the other important question is, how can I install the Pyomo? So this is really easy. I show you how to do it. So go open your Google and then type Pyomo installation Conda, and the first link that appears here is giving you the answer. So you go to that link, and it gives you the command for doing the installation of the Pyomo. Copy that piece, go back to your Anaconda editor, and then go to the environment, not the home, the second tab, environment. Go to the base root, open terminal. Once your terminal is open, paste the command here, okay? And that will install the Pyomo package. So what solver I should use? You can use IPOP, GLPK, or any other solver that you have the license for it, okay? So search the IPOP the same way and copy the installation piece here and put it in the terminal and install it, okay? You can also install the GLPK solver and do the same, okay? And that's it for the installation. Thank you very much. So visualization in Python. So in this course, when we solve the optimization problem, I usually prefer to show you how to visualize the decision variables and also the objective functions. So for this purpose, there are some multiple packages in Python, like Seaborn, like ggplot, like bokeh, like pygal, and also plotlib and geoplotlib, gleam, missing no, ladder, and also the main one that I'm going to use it throughout this course is matplotlib. So we can use these tools to visualize our decision variables and also the objective functions and how they are changing with the decision maker, okay? And also, so we don't have any insist of using any specific package in Python, but for simplicity I have chosen the matplotlib, but you feel free to change that part of the code and do the visualization by your own creativity. So in order to learn more about the matplotlib, you can Google it, and there is a website called matplotlib.org, and it has a gallery. It has multiples of solved examples, so you can easily use them. You don't need to memorize everything, of course, but if you need anything, you can go to the gallery and find out which of these examples are much closer to what you exactly need. So this is an example. For example, you need to import matplotlib.pyplot as plt and import numpy as np. And for example, in this plot, you can see there are some random shapes are scattered in the plane, okay? So this is the application of a scatter plot, and you finally show that plot to your audience, okay? So that's the way you visualize the things in Python. This is very simple, but you need to practice as well. Thank you very much.